I hope my screen is visible. Someone confirm? Okay. Today we will see the opposite thing. Yesterday we have seen how to do the conversion from the decimal to the equivalent binary representation, right? And today we will do the vice versa, from binary equivalent to decimal number. So this process is going to be very easy, right? After this we will start discussing about Java operators. Right? After this we will also discuss about the double data type, which is the one of the largest data type in Java primitives. Then we will start moving to the Java operators. So this is a 32-bit representation, right? If you see 32 numbers, 32 binary numbers. To achieve readability, I have just separated it in 4 bits each. Right? So from this, right, the first value is reserved for what? It is reserved for the signature, right? The next 8 values, 2, 3, 4, 5, 6, 7, 8. This part is reserved for what? This is reserved to represent the exponential value, right? And the remaining part, and if you count, we get 23. The remaining part is reserved for the fractional part, right? So we know the first part we already know. I don't think we need any discussion, right? So this is going to represent the signature. So in this case we have 0. So 0 means is always a positive number. You know this already, right? So I don't think any explanation is required for this one, or this most significant bit. Right now, right, to do the opposite, now we are converting from binary to the equivalent decimal number, right? For that, again we have 4 steps to be followed. So in the previous example there were only 3 steps, but in this example one more step is added, right? We will discuss that. The first thing is convert this. We will have to convert this to the equivalent binary representation, right? Let us do the conversion, right? So we have 1 0 0 0 0 1 1 0, right? Just add powers, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, right? And since all are zeros, I do not want to consider that. This is going to be what? Last number is going to be 2 to the power of 7, right? So this we get 128, right? So we will consider only the 1 powers, right? 128 plus 2 twos of 4 plus 1. Sorry, this one is 2. So we get 134. So this part is solved. The exponential component has been converted to the equivalent binary number. So this is the binary number, and so we should focus on one more thing here. Yesterday I was telling about something like a kind of word like bias, right? For now, if I say bias, just think that it is 127. The value of bias is what? 127, right? Yesterday we have used this bias, like if the exponent value is a positive number, we did addition, right? We do addition. I mean, I am talking about the yesterday's example. If it were to be a negative number, we do subtraction, right? So if you talk about this number as internally, the bias component is also there inside this number. When you say 134, 134 is nothing but 127 plus some number. 127 plus some number. Let us say that number is x, right? So this x is talking about the exponent value, actual exponent value. Instead of 127 pluses, I can say 127 plus e. Right? To extract this c, I can do the other way. Right? I can simply subtract 134 minus 127. Right? I will be getting what? The value of the exponent value, which is e. In this case, in our case, the value is what? It is going to be 7. Let me add. Yeah. So we have found this exponent value. This value is representing the exponent number. Right? So this part is solved. Now we should focus on this part. Only this part is remaining. Right? Understanding this part is very easy. Right? This, since it is representing the fractional component, right? This is fractional part. Right? So what we have to do, we have to convert this fractional part to the equivalent binary number. To do the conversion, right, for the whole number part, we use 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, like that. It goes like that. But for the fractional part, we do just what? 2 to the power of minus 1, 2 to the power of minus 2, 2 to the power of minus 3, 2 to the power of minus 4, 2 to the power of minus 5, 2 to the power of minus 6, and it keeps going like that. Right? This is how the fractional part will be represented, or will be, these 2 to the power of negative numbers is going to represent the fractional part of a binary number. 2 to the power of positive numbers are going to represent the fractional number of the whole numbers. Right? So I just need the values on top of ones bit. Right? What is the first value I have on top of ones bit? Because if you take the 0 bit, it has no significance. There is no use of taking the zeros bit. Right? We have only 3 ones. We will take those values on top of the ones bit. Right? In our case, we have 2 to the power of minus 1, right, plus 2 to the power of minus 3, plus 2 to the power of minus 1. So instead of writing like this, I can also write like this representation. 1 into 2 to the power of minus 1 plus 1 into 2 to the power of minus 3 plus 1 into 2 to the power of minus equal to. We need to find this. Right? So this one is going to be, if you multiply the number 1 with any number, the number is going to be the any number. Right? So 2 to the power of minus 1 plus 2 to the power of minus 3 plus 2 to the power of minus 4. Right? This can also be represented like, this can also be converted like 1 by 2 to the power of 1 plus 1 by 2 to the power of 3 plus 1 by 2 to the power of 5. Right? Mathematical concepts, we have studied this in our full days. I don't think you need much explanation on this. Right? So again, 1 by 2 plus 1 by 2 times of 2 to the power of 3 is 8 plus 1 by 2 to the power of 5 is what? 32. Right? So 1 by 2 gives us what? 0.5. And if you do 1 by 8, 2.5, 1.25, okay, 0.625. Plus for 32, 0.0312. You add these numbers, you will get what? 0.65625. Right? So this is the fractional part has been converted successfully to the decimal number. Right? So this part is also completed, and we have found the exponent value. We have got 2 values. Exponent value we got, the fractional value we got. Right? Now we need to do the actual conversion with a formula. The formula says minus 1 to the power of s. S is representing the most significant bit number, the value that is inside the most significant bit. In our case, it is 0 into 1 plus m. M is representing this fractional part. We call it as mantissa. Right? Into 2 to the power of e. Here e is representing our exponential value. Just do the direct substitution, you will get an answer. Minus 1 to the power of s is 0 plus 1 plus 0.65625. This is the substitution for m, right? Into 2 to the power of e. 7 is representing the e, right? So this is going to be what, 1 itself, right? Over 0 is going to be 1. I mean, can just replace it with 1 plus 0.62, sorry, 0.65625 into 2 to the power of 7, 1.65625, right, into 2 to the power of 7, right? If you do the conversion, 65625 into 128. Let's do this in the calculator. What is it? 1.65625 into 2 to the power of 7 is what? 128. We should be getting 212. So this is the answer. This is the answer. I have taken the simple example, right? If you want, you can try with the complicated examples. You can add, a lot of ones, and instead of zeros, you can add some ones here. You can find, or else you can take the exercise example itself, and you can try to apply the same logic, right? And please ensure that you are getting the same number that we have taken already. So you don't need to worry about these things. The reason why I am giving this much explanation for this particular flow data type is that you should be able to understand what are the things that are happening internally from the memory perspective. That understanding is required. And also, by definition, it says IEEE 754, right? You should know what is IEEE 754, right? My suggestion is you can work this out only once, right? You do not have to focus on this much, but this knowledge is going to help you out while you are thinking from the memory perspective, or while dealing with some codes, right? So that's why Java gives a lot of importance to the binary numbers, hexadecimal numbers, the octal numbers. In our school days, in our college days, we have been studying about these numbers without knowing what or where it is going to be used actually. This is where it is going to be used. We got an idea about the binary number and the hexadecimal number, and one number is pending octal number, right? We will also use that, on the go. Not now. We will get an opportunity to get to know about that number. Right? This is all about the float data type. Right? Now the next thing is double data type. Double data type. And if you know float, it is like you also know double. If not, there is not that we don't have much explanation for the double data type. To be honest, double color is not getting changed. Okay, double data type. Right. So the 4 points are the size. The size is 8 bytes. 8 bytes. So 64 bits. Internally 64 bits of registry will be created. If you apply the same logic for double data type, it is going to be very big number, very big binary number, and the calculations are going to be very difficult. So we will not work or do any calculations on double data type. So we will just assume the float data type. We will understand the float data type, right? If you understand float, understanding double is also easy. So these are the internal things. I do not want to want you to pay more attention on these things, but these are very important when you talk about or when you think from the memory perspective. Size is 8 by 64 bits, right? And second one is the default value. Default value is 0.0D. And the third point is, and if you talk about the size, even the double data type has no specific size because it is going to represent the big fractional numbers, a huge amount of fractional values. So the fractional values as always have no significance. It has least significance. You take currency can be represented in the fractional values, but up to the value is up to the two fractional values, right? After the decimal point, after that it has no value, right? Likewise, since it is representing the fractional values, no, the size is not defined. And but you must be wondering, yesterday sir, we have seen the size has been displayed from the online compilation. Yeah, that size is defined in the scientific notation, and if you do the conversion, right, the major part will be for the fractional values, right? The fourth point is it is not mandatory. For example, if you want to define a value on top of double data type, it is not mandatory for you to suffix the value with D. For example, let us say that double number equal to, if I have a number, floating point number, right? For the float data type, it is mandatory to suffix the float data type with F. But for double, it is an optional. If you do, good enough. If you don't do, also okay. It's not a compulsion. But for the float data type, it is a compulsion. As simple as. So this suffixing D is an optional. Suffixing D is an optional for the float data type. Sorry, double data type. Double data. And it is represented in IEEE 754 double precision standard floating. This is the representation, right? When you define these things, this is how you define, right? After giving this definition or after giving this theory, so there are high chances that you might be getting a question, getting a follow-up question like, what does it really mean? IEEE 754 double precision, right? You should be confident enough to answer this question. Right? It is a standard, it is a procedure to convert the floating point number to the equivalent decimal number to the memory register. Right answer, as simple as that. How to do that conversion? This is how to do that. And again, so if you talk about the bit registry, since the double is a very big number, isn't it? Even though it is a very big number, the most significant bit, the leftmost bit is reserved for signature. Let me write that here. The leftmost bit is reserved for what? That is reserved for signature. Sign bit. Right? And it has the exponent components, 11. 11 bits are reserved to represent the exponent value. In the float data type, the 8 bits are representing the exponential value, but in double, 11 bits. The remaining how many bits are going to be? 53 bits. 53, 63, 63, no, 52, 63, 52 bits. 52, 62, 63, 64. Okay. Remaining 52 bits are representing the fractional value. And you follow the same procedure. You will follow the same procedure, to do the conversion. But this is not our job. This is for our understanding. As simple as that. The computer is going to give do the calculations in seconds, even though it will follow a lot of compilation, lot of processes involved to execute the output, but the output is going to be in nanoseconds, not even seconds, nanoseconds. This is for our understanding. So if you know double, it means you also know float. If you know float, it means you also know double. Right? So much explanation is not required for the double data type. It is what it is. Right? By this I can conclude that, right, the primitive data types are completed. Right? Let us do a small recap. Right? How many primitive data types are there? Can you answer me? Answer it quick. How many primitive data types are there in total? Ganesh says 7. What about Samyukta, Sashwant, Darshini? Very simple question, guys. How many primitive data types? Just try to recollect everything. What are the data types that we have discussed so far? They are the primitive data types. How many types are there? How many are there? Ganesh has recorrected to 8. Samyukta, Darshini, no answers. Okay. Don't forget this. These are fixed questions. We have byte, and we have discussed about short. We have discussed about int. We have discussed about long. And we have discussed about boolean. After completing all this, we have discussed about boolean, and we have discussed about character data type. Character data type is a special data type because it's going to store number, Unicode, as well as the letter. And when you say letter, the letter can be from any language. It is special, isn't it? Character data type. And now we are discussing about what? Float data type and double data type. Covered. In total, how many are there? 8. 8. So now tell me, which is the smallest data type here? At least answer to this question. Among these, which is the smallest data type? Among these, which is the smallest one and which is the largest one? I mean, when I say smallest one, think about its memory. When I say largest one, think about its memory in the form of bytes. Boolean is the smallest one, correct, Samyukta? What is the largest one? Largest one, we are not sure. Why we are not sure? I will tell you. Because if you observe one thing, my memory, from the memory's perspective, Boolean is smallest. Boolean is going to consume only 1 bit of memory space, or it is going to occupy only 1 bit of memory space. Okay, right? But if you talk about the remaining data type, so this is how it is. Byte is of, when you say byte, it is going to consume 1 byte. 1 byte of memory. Short is going to consume how many bytes of memory? 2 bytes of memory. 2 byte, right? And integer is going to consume 4 byte of memory, and long is going to consume 4 byte of memory. Okay, and we have character. Character is going to consume 2 byte of memory, right? And float, again, you say float, it consumes 4 byte. Review my handwriting. When I say double, it is going to consume, sorry, this long is going to consume 8 byte. Yes, it's going to consume 8 byte. 8 bytes of memory, right? There is an ambiguity situation here because this long is also consuming 8 byte of memory and this double is also consuming 8 bytes of memory. So which one is largest? Which one is the largest, right? Because both are consuming same amount of memory. Right? So when you say largest, you can say long and double, since they are consuming the same amount of memory, both can be treated as the largest. That is completely correct. But when you talk about size, both comes into the picture. But when you talk about the experience, or when you talk about the promotion, there is a concept called promotion, promoting the data type. We will see what is promoting the data type. The vocabulary promotion I am talking about. Promotion. When you talk about promotion, or when you talk about the experience, something like, or when you talk about the handling the data, right? Double is, double is highly experienced. I will tell you, right? So this is how it is. Byte is like a child, and after byte short. Younger child, elder child, and we have int. Super elder child, we have long, right? After this, we have what? Float. After this, we have double. This is what the promotion is, and the character is going to be here. So you can assume it. So Boolean will not be part of this promotion, because Boolean will always stand separately. It is not going to be part of this promotion. Boolean is always separate. It is always unique, right? You cannot compare Boolean with these things, because Boolean is Boolean is holding that speciality in the primitive data types, where it cannot be compared with any other data type. Its nature is completely unique. So don't compare this Boolean with any other data type. It's an insult to Boolean data type. Right now we have in this case we have 7 data types. Right? When you talk about this, we know this is 1 byte. 1 byte. This is 2 byte of memory, 4 bytes of memory, 8 bytes of memory, 4 bytes of memory, 8 bytes of memory, and this is 2 bytes of memory. If someone is asking you, right, who is experienced, or who is capable of handling handling multiple values, I don't know. Let me put you in this way. In your college, if you go, right, you have a lecturer, right? So, and you will be having what? Lecturer has to report to what we call it as headmaster. Huh? What do you say? Head of the department, HOD. Forgot these things. And HOD has to report to vice principal, and vice principal will report to principal. Principal will report to chairman. This is the hierarchy, right? But there are high chances that this HOD and this chairman, right? When you talk about their age, they both are going to have the same age, right? Let us say he is 60 years old and he is 60 years old, right? So when you talk about age, both are same. But when you talk about the experience, or when you talk about the post, right? Chairman is not treated. I mean, he will be treated on top, right? Likewise, when you talk about the size, right? Long and double, they have the same sizes. Int and float, they have same sizes. But when you talk about the experience point of view, right? This float can handle integer data. For example, if you have a data like 80, this float can handle. At the same time, it can also handle floating point data. Experience is much experience. Even though it is smaller than long, still it is considered as the bigger data type in the promotion words. Try to understand. Right? Likewise, double. Even double is same as the size of the double is same as long. Right? When you talk about the experience, or when you talk about handling the data, right? Double is bigger. This is the promotion chart. Right? Why we need to know this promotion chart? We are going to see that in the operators class, in the next class. I'm giving you the basic idea about the promotion chart. Right? One, if anyone is asking you which is smaller, we have direct answer. Boolean is smaller. Right? Which is larger? We do not have, but you should be very specific in taking that question. Right? Very specific in the sense you should re-question, or you should ask them, like, you talk about the size of the data, long and double are larger in sizes. Right? If you talk about the promotion, if you talk about the promotion value, double is stronger or double is larger. Right? Making sense? So this is hierarchy. Very simple. Just remember this. B byte short, DSI, L long, L means long, byte short, I long, double, right? And character, so when you want to promote the character, it can be promoted to integer directly. So we will talk about the promotion thing in the next classes, but I'm giving you the basic understanding about the maximum data, I mean largest data type and the smallest data type, right? When I say largest data type, there are two largest data types. One is long, and another one is double. In context with the, this is in context with the size of bytes that it's going to consume. But when you talk about the promotion, double is the strongest value. It is in the top hierarchy when you talk about the promotion. When you talk about the promotion, the least value is byte. Promotion, least value is byte, not boolean. When you talk about the size, boolean is small. When you talk about the promotion, boolean, byte is small. Are you able to follow this? Just type at the chat box. Everyone. Or are you thinking why these things are necessary? These things are actually necessary while dealing with typecasting. It's also a concept in Java. Promotional things are very, very necessary. Good Samyuta. Ganesh, okay, Ganesh. Okay. Ashwant, okay, Ashwant. Okay. Right. So now you can answer, I think. Smallest data type is Boolean in context or with respect to the size. Largest data types are long and double with respect to size. But when you talk about the promotion, the smallest value is byte and the largest value is double. As simple as that. This is a promotion chart. And one more question I would like to ask. There is no concept of there is no concept of range for Boolean data type. Remember this. No concept of range for Boolean data. Okay, let us understand this. Let us take a small chart from online. Let us see how these things are written in the textbook. Okay, then we will come to this conclusion. Java data types. See, whatever I said, it is there itself. So it says single precision 32-bit IEEE 74 coding point value. Right. This is what the theory that you see in the books, textbooks. Right. If I am not explaining all this, understanding this theory is going to be very difficult. Yes or no? See? Single precision, and we must understand what is single precision. Right. I think I have justified you. I have given a lot of justification from the theory perspective. Right. So yes, everything is same. The character data. See the only 2 lines of information, but we have discussed this for almost 2 classes. Okay, now the new topic, operators. So this topic is going to be very interesting to participate. Java operators. Let me save this. So there are many operators in Java, but most of the time this is the interview question that you may encounter. Very simple interview question. Try to answer this. I will explain you. Okay, in Java we have an operator called increment operator, the decrement operator. Right? I will tell you what is increment operator and what is decrement operator. For example, let us say that I have a class test. Public static void. Let me bring this in the. Let me bring this. class text public static void main string array box. Now I should I'm expecting answers from you. The question is integer a equal to system dot println. Very simple question. After this, we will look into the actual problem. What is the answer for this? Please drop your answers in the chat box. Test dot. Please drop your answers for this. Okay, 10. Straightforward. No, don't think any explanation is required for this. Right, now the actual question comes. Let me change my directory ID cd space java c space test dot. Before even getting into the question, and there is an operator in Java, plus plus operator. What does it really mean? When I say a plus plus, when I say a plus plus, this a plus plus is also like a equal to a plus 1. To understand this, let us make some small changes. Right? A equal to a plus 1. Now what is the answer for? Now what is the answer? Answer 11. Good. What you have answered is correct. A equal to a plus 1 is equal to 11. You are correct. Right? Now, so in Java, so a plus plus, this a equal to a plus plus, this is equal to a plus 1, can also be represented like a plus plus. Right? A equal to a plus 1 can also be represented like a plus plus. Right? So now I am saying a plus plus here. Understand my question? Very simple. I was saying in Java a equal to a plus 1. If you want to represent this, you can either choose to represent like this or you can choose this. Both are same. When I say a equal to a minus 1, this is like a minus minus. Both are going to be same. Right? We will go deep into this, but my I just want to understand whether if you know these things or not. When I say a plus plus, now can you tell me the output? $11. Samyukta says 11. Oh, 11. Let us run this. 10. Why we are getting 10 now? I will tell you why. This is also an interview question. Right? So this question was put in the chat box. It was asked. Right? The person, he was told to put the answer in the chat box. Right? He said 11, but it was not 11. It is 10. Why 10? Let us understand this. Let me remove this. So this concept is called post increment, right? And we will discuss these things in the post increment operators. There are many operators in Java, and increment operators are one among them. So now we got to know how the things gets represented internally, right? From now on, we are not going to represent anything in the binary number. This for our understanding, we have chosen to learn things like that, to convert binary and again extract it to the decimal number. Right? From today onwards, we will think everything in the decimal itself, right? So first line, so compilation happens and execution happens, and the main thread will be created inside the JVM, and main thread will try to get access to the main method, right? And the first instruction is integer a equal to 10, right? 4 bytes of memory will be allocated, and you just imagine, right? 4 bytes in the sense 64, I mean 32 bits, right? Just imagine, but for now I am saying a inside this 10 is going to get assigned. This is what happens for the first line, right? When the control comes to the first line, this is what is happening internally. The memory value 10 is getting assigned to the variable a, right? And the control will be transferred to this next line, second line. So in the second line, we are saying a plus plus a post increment, a post increment, right? But what system will do? Now we focus here. When you say a plus plus, right? First a post increment, I'm giving spaces for the readability, okay, right? So from the system will give priority from left to right. Left to right the priority. Right? When you do post increment, right? First it will see the variable a. It will notice the variable a. Right? It will notice the variable a. As soon as it sees variable a, the value of a will be displayed to the console. First thing. As soon as it finds the variable a from left to right, the value of a will be displayed in the console. Then it will perform the post increment operation, which is a equal to a plus 1. Now what happens? It encounters a in the console in our system, right? Value of a is what? 10. 10 will be printed. Console 10 will be printed. But in memory, right, after printing the displaying the value 10 to the console, it will perform the increment operator. It will perform the operation on top of this post increment, which is adding 1 to the a. So this time from the memory 10 will be replaced with what? 11. 11 is getting stored in the memory, but when it comes to display, 10 is getting displayed, right? Post increment is post increment, and we will see a lot of problems on top of this post increment, but this is a basic idea. I'm just introducing this to you. So this is one of the interview questions. So we expect the value to be 11, but the value is 10. Why value is 10? Because, right, when you say when you use post increment operator, post increment is after the variable you will represent the operator. After the variable you will represent the operator. First it will seize the variable, right? Without doing anything, it will display the value in the console. Then it will perform the increment operation, and the value of 11 will be stored inside the memory. As simple as that, right? So let me take one more example. This post increment, right? Now we have pre-increment. Pre-increment is, right, just prefix 2 plus symbols before the variable. This is pre-increment, right? Now you tell me what would be the value. Just guess. Just give a guess. Can you guess this value? Can you guess this answer? Pre-increment. Ganesh says 12. Others? 11. Okay, 11. Darshini? Darshini says 11. Okay, good that you are trying. Let us track this. Okay, first let us try to run this. Okay, answer is 11. Who said 11? Big round of applause to those guys who said 11. Darshini, Ashwa, Samyukta. Okay, okay, Ganesh. No issues. Second example, pre-increment. Now focus here. Now guys, focus here. It will be a little confusing. This is pre-increment. Pre-increment is prefixing the plus operators before the variable. Two plus operators before the actual variable, integer variable. Okay. Again, the main method will be created. Main method will try to get access to the main method. Right. All the instructions inside the main method will get executed. Right. First instruction is very straightforward. Right. Int I equal to 10. Assign the value of 10 to the variable A. Set the memory. Right. 4 bytes of memory will be created, and A, this is A, right, and this is 10, right. So this value of this A is holding the value 10. Okay, first line got over. Now the control will be, now the control jumps to the second line. Second line. Okay. The second line, inside the system dot out dot println, inside these brackets, first it is finding the operator plus A. So this is a pre-increment operator, right? For post increment, the concept is very simple. First print the value, then update. Print and update. For pre-increment, operator, update the value and then print. This is the formula, simple formula. Print and update for post. This is pre-increment, right? What happens pre-increment? Plus A. Update the value in the memory. Right? The value in the memory is 10. Sir, no. 10. Plus means 10 has to become what? 11. Right? So updated is successful, then print. Right? It will try to map the value of A now. Now the recent value of A is what? 11. So that's why 11 will be displayed. The concept. Making sense? Right? Post increment, right? If you do this, if you take this, if you see this A++, this is called as post increment. Right? In this case, value will be displayed to the console first, right? Then the update will happen in the memory. Right? When you say pre-increment plus A, this pre-increment, right? Update the value in the memory, then print. So when you say print, every time, when it has to print, the value will be fetched from the memory only, right? Yes or no? Right? That's why in this case we are getting 10. In this case we are getting 11. Right? This is a simple example. On top of this, we'll discuss a lot of things. There are many operators in Java. A simple example. One more question let me ask you. Right? Now I am taking 100. A minus. Let me now you tell me. So this is the question. Think and tell me. Think, take your time and tell me. I have used two print statements. Think and tell me, everyone. Ganesh says 100. Okay. Samyukta, Darshini, Shashwant. Give me a try, guys. Samyukta says 100. Darshini also says 100. Shashwant says 99. Okay. Thank you for the try. Java C space test or Java space test. 199. So who said 100? So okay. First one is close to the answer, but everyone are close to the answer. One of the answers are correct, but one of the answer is wrong. Okay. Let us analyze this. Pay some attention. Don't worry. We'll see a lot of problems like this. After understanding this, we will be very comfortable to solve any Java problem on top of calculations. The time box is here. Okay. Okay. Your question. Main thread will be created, right? Main thread will try to get access to the main method. Right? First instruction is what? This one. Even if you have pen and paper, you just imagine the things like this. Okay. For the few classes, then you don't want to do this. This is for our understanding the control. As simple as that. Int equal to 100. Okay. For this instruction, memory will be created, right? And A will be A is an identifier for the value 100. So the value 100 will get assigned to the variable A. This is inside the memory. We don't see this. This is happening inside the memory. This is our imagination. Okay. So this is what we see. We have to see. We are saying A minus minus. A minus minus means I can also say that first print the value and then update. Right? What is the value of A? 100. So let me understand this concept. What is the value of first print? 100 will be printed, then update. What needs to be updated? A minus minus means A plus plus means add 1 to the number. A minus minus means reduce 1 to the number, 1 from the number. Right? 100 will become 99. This is the latest value. Let me put the latest value as 99. Right? So this line over. Now the control will be transferred to, right, previous it was here and now it will be here. Right? Now we are trying to access what? We are trying to access it. Right? No increment, no decrement, just direct value is the try to access it. What is the recent value of A? 99. 99 will be displayed in the console. You see output 199. What we got? Yes or no? That is my comment wrong. 109. Making sense? Type yes in the chat box if you have understood this. Let's see another example. So, yeah, one more example. Pay some attention. These are the set of interview questions. It may look very simple. By looking at it, you will pay, hey, let me crack this interview. It is very easy. No? You will feel like that. So now I am taking A plus plus A. Okay, think and answer. Think and answer. A is 12. No, first we have 3 system.out.println. Think and answer. Twelve, 13. That should be 3 answers because 3 system.out.println. So 3 values should be displayed in the console. 12, 13, 12. Okay, let's see who is correct. 12, 13, 13. Okay. What about others? 12, 13, 13. Response is typing still. That's it. Okay, let's see. Let's see the answer. Let me save this. Java C space desktop Java. Java C space 12, 14, 14. Right? Did anyone say 12, 14, 14? Yes, no. 12, 13, 12, 13. Okay, why we are getting 12, 14, 14? Right? Why we are getting? So let us trace this. Tomorrow, when you practice, take a pen and take a paper and do the practice. So that will help our imagination. Okay. Let me keep it black. Okay. Main thread. So compilation, execution, we know. Compilation stage, we will start discussing from the execution. This main thread, all the instructions inside this get executed, right, one by one. First line, each and every line has its own significance, its own importance. Okay, so a equal to 12, right? So when I say a equal to 12, the value 12 will be assigned to the variable a, right? Internal things, right? So 12 will be stored, and now the control will be transferred to the second line. A plus plus, A plus plus, A post increment. Post increment means print the value. Says first print the value. Value is what? 12. Then perform the increment. After printing the value, increment needs to be performed. So 12 will be in what? When you do increment, 12 plus 1 is going to be 30. In the memory, now the value is 30. Right? Now the second line. Second control will be low. Now it says pre-increment. Pre-increment is what? Increment the value. Post increment is print the value increment. Pre increment is first do the changes in the memory. 13 has to be what? 13 has to become 14. Right? Do the increment and print. Now print is pending now. 14. Right? Now what? We are accessing A. What is the recent value of A? 14. Right? Bottom line is very simple. A plus plus for post increment. For post increment. Okay. Sorry, we got due to the time restrictions. Okay. I was saying, right? The bottom line is when you see post increment, two operations has to be performed. One is print, then update. Pre-increment, two operations again, update and then print. Right? Print means console, update means memory. Update means memory, print means console. If you remember these two, solving these problems are going to be very easy, right? Let us go back to another problem. We have 9, right? To answer this, a equal to 9, right? There are 5 println statements. It means 5 values needs to be displayed in the console. Right? You should think what value will be manipulated inside the memory. Think and tell me. Right? The value of a keeps getting manipulated, updated, right? At the same time, five values will get displayed in the console. What are those five values? Try to give it a try. Don't 9, 10, 11, 12, 12. Okay. You print, I will copy and paste this. Let's see who is giving the right answer. Okay, 9, 10, 11, 12, 12, 9, 10, 11, 11, 12, 9, 10, 11, 12, 12. Okay, I got four answers. So let's do compilation. Let me save this. I forgot to save this. Nine, 10, 11, 12, 12 is the right answer. 9, 10, 11, 12, 12. We'll trace this. 9, 10, 11, 12, 12. 9, 10, 11. Samyukta is right. Person is little wrong, close to the answer. 9, 10, 11. Sashwant is right. Ganesh is also right. We'll understand this, huh? No worries. Main thread. Main thread gets access to main method. All instructions on the main method is to get executed. The value 9 value has been assigned to the variable A. Right? Now we will see the operations. The first line A plus plus. Right? A plus plus A post increment. Post increment means print the value. Print the value in the console. Then update. Right? So 9 will be printed in the console. Right? And the increment operation will happen. So no, 9 will become 10. Right? Now, right? So we are directly printing printing what? Printing A. So the recent value of A is updated to 10. So 10 will be printed. Right? Now we are doing plus plus A. So plus plus A means update and print. So update in the memory, print in the console. So 10 will be updated to 11. Now print in the console. Updation has happened, right? Now we need to print this. Okay. This line is done. Right? And again, now we have to be this line. Right? Update and print. So 11 will get updated to what? 12. Print the value of 12. Lastly, we are just printing the value of A. The recent latest value of A is what? 12. 12, right? No updation is required because directly we are printing the value. So 9, 10, 11, 12, 12. This is what we got. 9, 10, 11, 12, 12. Making sense? Question making sense? Able to follow? Jashwant, Samyukta, Ganesh. Right? This is all about today. And tomorrow we will focus. We will start